Hey guys, I'm Cyborg Sheep, and welcome to the Weekend Post. In this video, you ever wondered what's inside one of these here chop saws? Well, today, we're gonna find out. So before we get started tearing into this thing, take a look at the features on this thing. So this is a sort of an older saw, Black & Decker. It can adjust the angle through this knob right here, and it plunges to take the cut, of course. There's no sliding feature on this saw because it's just a small saw, nothing too major. Based on what I've seen, the build quality on this is actually pretty half decent. Like, metal construction pretty much throughout, minus the guard and handle motor, just because electrical components are there, so they keep it double insulated so they don't have to stick the ground in and the extra conductor. I checked it with a square. This is actually surprisingly good for being square. Miter saws aren't generally known for that. Table saws are generally better at that job. But yeah, without any further ado, let's start taking her apart. This is kind of funny. Danger! Keep your poking sticks away from the cutting end. Yeah, obviously. Of course, the blade guard does come off, so you can change the blade. Of course, the blade itself, this is an aftermarket, I believe. I don't remember the exact details of it, but it's been used a little bit, and pretty nice cutting edge on it still. Affixed to the saw with one bolt, or rather fixed to the arbor rather, with one bolt and just a washer there to keep it centered. Got the brush holder right here, and I noticed some interesting features on this. This isn't metal, it's plastic, which this thing is getting frickin' hot because this basically the way the motor in here works is that alternating current electricity will be applied between so let's see here. So will be applied between this brush holder and this brush holder, and it'll transfer from the brush holder to the, I don't know if you can see it in here, let me see if I can get you a closer look. Let's see if we can get a shot in there. It will transfer over to those copper bars right there, and that's called the commutator. And then those copper bars are wired into coils, which will create an electromagnet. That electromagnet will be attracted to there's another electromagnet right there, and that's called the field winding, and that one on there, that's the armature winding. The armature will be attracted to the stator right there, the field winding, and it'll rotate. But then, since this copper ring is segmented, and there's multiple coils on the armature, when it moves, it switches over to the next coil, and then it gets attracted again, switches over, gets attracted again, and the cycle repeats. But at 120 volts though, you're going extremely fast because the attraction between the rotor and the stator, or the armature and the field, is so strong that it's spinning extremely fast. What does that mean for these brushes though? So these brushes are touching against the armature, and they're held touching on the commutators, what it's called, by springs. But this thing's spinning so fast, this thing, she gets Jesus hot. So the fact that this is plastic, I'm surprised this thing didn't fail with that. Although that said though, this wasn't used that much, of course, so not surprised. Okay, taking these last 3 screws out though. Alright, and then in theory, both of these should come off as one unit. Aha! Just like that. Okay. Now there we go. That's a good look at this armature. So this is kind of interesting. It's made of all these little different sheets. You wonder why that is because basically when you have magnetic fields passing by conductive metal, it creates a current in that metal, and they're called eddy currents basically. Especially when you have a alternating field, that happens a lot. So those eddy currents will create heat. You don't want that, so what you do is to limit the amount that happens, you basically turn this into, instead of one solid chunk of metal, you just slice it up into a bunch of thin slices. And then that way, since they're electrically isolated, it's only the individual slices that'll be induced into, but not to one solid piece, which would heat up and be really inefficient. But something interesting on this armature that you can see, they've cut out pieces from it. Why that is because when this thing gets spinning really fast, and of course this wouldn't be perfect, so if this thing were to be spinning really fast and they hadn't put those in, this saw would be vibrating very violently. Well, not crazy, but you know, there would be a lot more vibrations in it than if they had put these in. So they cut those out just to keep this rotor relatively stable while it's up at high speeds. And yeah, pretty interesting couple of things I noticed. Look at these commutator bars. They're huge. Oh, that's crazy. The one thing that I do notice though, they haven't put like adhesive over these connections here, so those will rattle out and this will be hoopa-jooped. Couple more interesting features on this saw. You got a little guard here just to keep the ball bearings out. And this fan, interesting feature. Yeah, so this thing spins this way because the fan vanes, they scoop up air, blow it out this way, so that means it's sucking in from the back and blowing out towards the blade. So there we go. But this armature, it seems like it's just gonna pull out. Oh, look at that. Oh, that's cool. So this, oh, that's interesting. So this has a pinion built right into the shaft here. And that's, so yeah, machine right into the shaft, and then, wow, okay. Alright, so I suppose the last mystery to solve is how to get this blasted blade off of here. I was hoping I would find some sort of like locking feature or like some sort of like flats on the armature end, but there's nothing whatsoever. So I'm kind of screwed. So what we're gonna do is we're gonna take these channel locks here and just hold the arbor, and then see if we can get that nut off the other side. Aha! I found a solution. Stupid like a fox. Well, that was fun. Some science and engineering behind how these saws work, and a teardown video. Lots of fun. I have something planned for this saw that I think you guys are gonna like, but I think for now I'm gonna leave it at that. So, hope you guys enjoyed. Subscribe so you don't miss the upcoming video about this saw. Hit that like button if you liked it, and I'll see you guys in the next video.